All right, welcome to the Python Roadmap. In the next few minutes, think of this less like a lesson and more like a high-speed tour. We're going to travel from the simple idea that code should be beautiful all the way to building the kind of complex applications that pretty much run the modern world. So let's get started.
This right here is the core promise of Python, and it's honestly what makes it so revolutionary. Most programming languages, they're designed for computers first, humans second. Python completely flips that on its head. It's built on the belief that the person reading the code is just as important as the machine running it. And that's not just some nice-to-have feature, it's the entire foundation. So, to really truly understand Python, we have to start where its creators did, with a philosophy. Before we even write a single line of code, let's dig into the core belief that shapes every single part of the language. This isn't just a nice little suggestion, it's basically the law of the land in Python. This single idea, it's from a thing called the Zen of Python, and it dictates every single design decision. If a feature makes code harder for a person to read, it gets rejected. Simple as that. Clarity is completely non-negotiable. Okay, so with that philosophy as our compass, let's look at the actual building blocks. How does this big idea of readability translate into the real nuts and bolts of the language? We're moving from the why to the what. And this is where that philosophy gets physical. Most languages use things like curly braces or keywords to define blocks of code, which, let's be honest, can get pretty messy. Python uses simple indentation. This literally forces your code to be visually organized, making its structure instantly clear. What you see is actually what you get. Now, this distinction is absolutely crucial for writing safe code. On one hand, you have lists. Think of them just like that shopping list. You can add items, remove them, change things around. On the other hand, you have tuples, which are more like a photograph, a snapshot, frozen in time. They're immutable. And this isn't a limitation. It's a feature. It's how you make a promise in your code that some specific data will never, ever change. So these are your four main tools for organizing data. You've got your changeable shopping list, your permanent photograph or tuple, a set, which is basically a bag where every item has to be unique, and a dictionary, which works just like a contact list, linking a name to some information. Each one is purpose-built for a specific kind of job. Okay, so we have our ingredients, our data. Now, how do we cook with them? This next section is all about structuring your logic, creating the recipes that turn all that data into something useful. Functions are the absolute bedrock of any serious program. They let you package up a whole complex process, give it a simple name, and then just reuse it over and over. It's the difference between writing out every single step of a recipe each time and just being able to say, make the dough. You get to hide the complexity and just focus on the result. Now here's how Python deals with the inevitable fact that, well, things go wrong. Instead of just crashing, Python gives you this try/except structure. It's like having a built-in plan B. You try to run the risky code, and you define exactly what to do except if it fails. This is how you build robust programs that don't just fall apart at the first sign of trouble. We've built functions. Now it's time to scale up. How do we take all those individual recipes and organize them into a big, coherent, large-scale system? It's time to start thinking like an architect. And this is a core distinction. Modules are about physical organization, keeping your files tidy and focused, kind of like chapters in a book. Classes, on the other hand, are about conceptual organization. They're for creating blueprints of the complex ideas and relationships that actually live inside your application. Which brings us to object-oriented programming, or OOP. And it's way more than just a technique. It's a way of thinking. It lets us model complex, real-world things, like a user, a car, or a bank account, as these self-contained objects in our code, where each one has its own data and its own behaviors. This is how we build really complex systems that are somehow still manageable. So let's connect that architecture to the real world. How do these ideas actually come to life in the massive community ecosystem of frameworks and all these shared tools? This is a total performance game changer. The big insight here is that for a lot of apps, the biggest bottleneck isn't the computer's processing power. It's simply waiting, for a network response or a database query. Asynchronous frameworks let your program do other useful work instead of just sitting there idle. And as you can see, the result is crazy. It can take a task that took 13 seconds and get it done in under a second. This number, this represents Python's true superpower. It's community. The Python Package Index, or PyPy, is a massive public library with over 500,000 packages of shared code. It is the collective work of a global community, all just sitting there, ready for you to use. So we've got the logic, we've got the architecture, and we've got the tools. The final step is mastering the disciplines that make our code trustworthy, maintainable, and actually built to last. And look, these aren't just chores, they are the absolute pillars of professional software. Clarity gives you the confidence to make changes. Consistency makes the code effortless for anyone to read. Accountability proves it actually works. And context makes sure the why is never forgotten. You really do need all four. So that was the journey. Let's do a quick rewind. It all starts with the foundation, right? Clean syntax and fundamental ways we store data. From there, we start to build on top of that, crafting reusable functions to structure our logic and actually bring that data to life. Next, we zoom out and start to think like architects, using object-oriented programming to create these powerful blueprints for much larger, more complex systems. And finally, we plug our architecture into that global ecosystem, using all those amazing community-built tools to create powerful, real-world applications. And there you have it, the complete roadmap. You see, it's not just a list of topics, it's a logical progression. Each step builds directly on the one before it, taking you from a core philosophy all the way to professional craftsmanship. So, now you have the map. You can see the entire journey, from a simple idea all the way to a finished application. The path is clear. The only question left to ask is, where will your journey begin?